So, welcome you all again to this class on electric vehicles. In the previous class, we had an introduction to electric vehicle and the history of electric vehicles. Now, we will go to the types of electric vehicles. The electric vehicles can be classified into different groups, like first one is battery electric vehicles known as BEV, second one is a hybrid electric vehicle, and third one is a fuel cell electric vehicle known as FCEV. And the hybrid electric vehicles again further divided into two types. One is the hybrid electric vehicle known as the HEV, second one is plug-in hybrid electric vehicle known as the PHEV. So, this battery electric vehicle is basically a fully powered by electric source only, electricity only, and this type of electric vehicle, that means the battery electric vehicles are the more efficient compared to the other two types of vehicles like hybrid and plug-in hybrid vehicles. The hybrid electric vehicle uses both a conventional IC engine, normally a petrol engine, along with a battery powered motor powertrain. And the petrol engine used to both to drive and charge the battery when the battery is empty. And these vehicles are not very efficient as that of a full electric or a plug-in hybrid vehicle. Then is your plug-in hybrid vehicle. A plug-in hybrid vehicle known as PHEV, it basically uses both a conventional IC engine and battery charge from an external socket. So, here please try to understand, in a hybrid electric vehicle, there will be no point to charge the battery receives the power from the conventional petrol engine only, whereas in a plug-in hybrid vehicle, the battery receives charge from the external power socket. So that here the vehicle's battery can be charged with electricity rather than using the energy from the engine itself. That is why these plug-in hybrid electric vehicles are more efficient than the hybrid electric vehicles, but it is less efficient than the fully powered battery electric vehicles. Then the last one, that is the fuel cell electric vehicle. In fuel cell electric vehicle, basically we produce electricity from the chemical energy using a fuel cell. For example, it can be a hydrogen based fuel cell, where the energy produced in a fuel cell is used to charge a battery, and the battery provide the energy for driving the electric vehicle. Next, we will go to the topic to understand the system architecture of electric vehicles. The first one we will consider is your battery electric vehicle, popularly known as the BEV. So, here you can see this BEV, that is battery electric vehicle, also known as all electric vehicle, that is AEV. And here you can see this battery electric vehicle technology runs entirely on a battery powered electric drivetrain. So, that means a battery pack will be installed inside that electric vehicle, which is connected to the electric motor, and this electric motor is connected to the driving shaft. We charge the battery by giving external power input to the battery, and when we want to drive the vehicle, we need to provide energy to the electric motor from the battery itself. So, the electricity used to drive the vehicle is stored in this large battery pack, and this battery pack is charged from time to time by taking electricity from the grid. And this charged battery pack then used to provide the power to the motors of the electric vehicle. There may be a single motor or multiple motors in an electric vehicle based on the design of the electric vehicle. Here are the main components of this battery electric vehicle. First one is a electric motor, then there will be an inverter, a battery, control module, and the drivetrain system of the electric vehicle. The working principle of battery electric vehicle is very simple. The power for the electric motor is converted from the DC battery to the AC, because you see we store the energy in the battery in the form of DC, and the electric motor drives on AC current. So, we take the DC power from the battery first to convert into AC, then you use that energy to drive the electric motor, which basically again drives the wheels of the vehicle. The accelerator, when the accelerator is pressed, a signal is sent to the controller, and the controller will do the adjustment of the speed of the vehicle by changing the frequency of the AC power from the inverter to the motor. The motor will then connect and lead the turning of the wheels through a cog, and if the brakes are pressed, the electric car will start decelerating, and the motor becomes an alternator which produce power which can be again used to charge a battery. If we try to know which are the practical electric vehicle models are available today which can be classified into battery electric vehicles, here is a very big list like Tata Nexon, a very famous EV in India, Tata Tigor, Mahindra E20 Plus, Hyundai Kona, Mahindra Bharito, MG ZS are the best examples of battery electric vehicles being available in India. Then we will go for second one, that is hybrid electric vehicle known as HEV. These HEVs are known as series hybrid or parallel hybrid, and these hybrid electric vehicles have both engine and electric motor, as you can see here in this diagram. The engine requires the conventional fuel, either petrol or diesel. So, there will be a fuel tank will be there, and we will fill this fuel tank and whenever we want to drive the engine, it will receive the fuel from the fuel tank, and then it will give power to the drivetrain system. And the transmission is rotated simultaneously by both engine and electric motor. So, here we can see we take the power from the battery to run the electric motor, and the motor is again connected to the engine. That means, here the electric motor is not directly connected to the wheels of the power system, but rather than it is connected through the engine. And here the main components of this hybrid electric vehicle are the engine, a electric motor, the battery pack with controller and inverter, a fuel tank to provide fuel to the engine, and the control module of the hybrid electric vehicle. The working principle again here is very simple. The fuel supplies the energy to the engine in a conventional car, and the batteries run by taking electric, the battery provides the source of energy to drive the electric motor, and both the engine and the electric motor, it can turn the transmission system as per the requirement. Next, we will go for plug-in hybrid electric vehicle known as PHEV. These plug-in hybrid electric vehicles are also known as series hybrids, because here you can see we have a fuel tank connected to the engine, engine is connected to the drivetrain, and drivetrain is connected to the wheels. Then you have a electric motor that takes power from the battery and connected to the engine as well as to the drivetrain system, which can drive the wheels of the vehicle. So, engine and electric motor, they can independently at different times can run the vehicle separately, and the battery can be charged here externally. And this plug-in hybrid electric vehicles, it can run in at least two different modes. The first one will be your all electric mode, where we use the energy from the battery to run the electric motor, which basically drives the vehicle. And in the hybrid mode, we take both electricity and the petrol or diesel as the source of energy, where battery is used to drive an electric motor, and the conventional petrol or diesel based fuel is used to drive the engine, and together they drive the vehicle. And the main component of a plug-in hybrid electric vehicles are electric motor, engine, inverter, battery, fuel tank, the control module, battery charger, when you install a onboard model for the electric vehicle. The working principle is again very simple here. We consider the fuel as the source of energy, or the energy in the battery as the source of energy, where the battery can be charged from external power input, and the fuel can be used to run the engine, and the engine as a single unit can run the drivetrain system, or the electric motor as a single unit can also run the drivetrain system. So, the engine's power is supplemented by the electric motor, where when you do this one, this smaller engine can be used which basically increases the car's fuel efficiency without compromising the performance of plug-in hybrid electric vehicles. Here is the list of plug-in hybrid electric vehicles available across the world. You will find out BMW 330e, Mercedes C350e, Mercedes S550e. Then you find out Audi A3 e-tron, BMW i8 and Hyundai Sonata, Kia Optima, Volvo XC90T8 are the few models that basically work on the principle of hybrid electric vehicles, plug-in hybrid electric vehicles. Then we will go for the last one, that is fuel cell electric vehicle. This fuel cell electric vehicle, also known as zero emission vehicles, because they use the fuel cell technology to generate electricity inside the vehicle itself, where the chemical energy of the fuel is converted directly into electric energy and it does not produce any kind of emission as a whole. The main components of a fuel cell electric vehicle includes electric motor, fuel cell stack, hydrogen storage tank, battery with converter and the controllers. The working principle is very simple. This fuel cell electric vehicle, it generates the electricity and this electricity is used to run the electric motor. Also it is connected to the battery to do the charging of the battery system. Here is a list of vehicles that can be classified as fuel cell electric vehicles, like Toyota Mirai, River Simple Rasa, Hyundai Tucson FCEV, Honda Clarity fuel cell and Hyundai Nexo are the electric vehicles use fuel cell as the source of energy to drive the vehicle. Next we will go for the benefits of using a electric vehicle. The first benefit of using a electric vehicle is its low running cost because it is highly efficient drivetrain system. The second benefit of using electric vehicle is the overall maintenance cost is very low because it has very less number of parts and all these parts are in a covered system. So, that is why the overall maintenance is less. Then third one is your zero tailpipe emission because here it uses electric energy from the battery to drive a motor. As such, it does not produce any emission. So, we get zero emission out of a electric vehicle physically. Then overall we get zero emission here because EV does not produce any kind of output during the drivetrain system, and it is very convenient and easy to drive a electric vehicle because of its emerging technology. And these electric vehicles can be charged conveniently at our residence also. We are not bound to use any public charging system. Of course, if the facility of public charging system is available in the city, that is an added advantage. Otherwise, it can be charging can be done at the home itself during the parking hours. Overall, electric vehicle is very quiet in operation compared to a conventional petrol or a diesel based vehicle. So, conventionally diesel based vehicles are relatively petrol based vehicles are relatively quiet in operation than diesel based vehicles. However, electric vehicles are still quiet in operation compared to the petrol based vehicles also. Finally, central and provincial governments provide different kinds of tax and financial benefits for persons who would like to purchase a electric vehicle for their use. So, here now we will discuss what are the different types of tax and financial benefits one can avail for using a electric vehicle. So, first one we provided is purchase incentives. So, where direct discount is provided to the user on the overall cost of the electric vehicle. Then coupons are also available where financial incentive is the amount is reimbursed as a later. We can consider this to be a cashback coupons also. Then interest subventions like discounts are offered on the interest rate uh, while you avail a loan for purchasing a electric vehicle. Uh, when you want to register a electric vehicle, the road tax at the time of purchasing is being waived off in most of the cases, and that also reduces the cost of a electric vehicle. And the registration fee, there will be some exemption, because you see, when you purchase a vehicle, you do a one time registration for which you need to pay a fee, and this fee is being waived for new electric vehicles. Government also provides income tax benefit in the form of deductions uh, on the tax amount that is payable by an individual to the government. Then there is a scrapping incentive which is provided when you deregistered your old petrol or diesel based vehicle and you purchase a new vehicle, because you are shifting from a conventional polluting vehicle to a cleaner electric vehicle. Then you also get other kind of incentives like interest free loans, top up subsidies, special incentives on electric three wheelers can also be availed, that is available from time to time. If we talk about what is the incentives available in India at the national level, there is a organization known as FAME, Faster Adoption and Manufacturing of Hybrid and Electric Vehicles. This FAME is presently India's flagship scheme, whose objective is to promote electric mobility. Presently, this FAME scheme is in the second phase of the implementation, which started from 1st April 2019, still is in operation in the first month of 2023. In the second phase of FAME, the Government of India has provided a budget allocation of 10,000 crore to be given as incentives to the user or purchase owners of the electric vehicles. Here you find the total approximate incentives you get for different battery size electric vehicles. Like if you are going to use a two-wheeler where the approximate battery size is around 2 kilowatt, one can avail up to 15,000 rupees per kilowatt, up to 40% of the cost of the vehicle as the incentive. Then three-wheelers, normally battery size remains 5 kilowatt hour, you can avail around 10,000 rupees per kilowatt hour as the incentive. Four-wheelers, around 10,000 per kilowatt hour, where four-wheelers have 15 kilowatt hour battery is there. So, you are getting around 1.5 lakh as the incentives. Then for electric buses, one can get 20,000 per kilowatt hour, and the typical size of battery for buses is 250 kilowatt hour. And for trucks, again government is providing 20,000 rupees per kilowatt hour as the incentive. So, here you can see the under this FAME 2, government has the plan to provide subsidy or incentive to 10 lakh electric two-wheelers, 5 lakh electric three-wheelers, 55,000 electric four-wheeler passenger cars, and 7,000 electric buses across the nation during the second phase of the FAME. Out of the total budget available of 10,000 crore, 86% of this fund have been allocated for demand incentive, basically with the objective to create demand for the electric vehicles in the country in the coming years. Those who are interested to know more about this FAME scheme, you can visit to this website of Heavy Industry Department of Government of India, that is fame2.heavyindustries.gov.in. Only advanced battery and registered vehicles will be incentivized under this scheme of FAME 2, with greater emphasis on providing affordable and environmental friendly public transport systems for masses. The scheme will be applicable mainly to vehicles that use public transport or those registered for commercial purposes in uh, electric 3 watt, electric 4 watt and electric bus segment. However, this privately owned registered uh, electric two-wheeler also covered under this scheme as a mass segment in the FAME2. In addition to the uh, incentives provided by Government of India, different state government also provide different kind of incentives from time to time in their own regions. More details you can find out on this website e-amrit.niti.gov.in/state level policies. Uh, Next we will go for what are the common myths people come across and what we should do for busting this common electric vehicle myths, uh, which is very essential to adopt electric vehicles in the coming days. The first myth is electric vehicles are very uneconomical. The reality is that electric vehicles are actually more economical when you consider the cost of the fuel for daily use and the maintenance cost you incur over the time. However, we have to accept that the initial cost of electric vehicle is higher as on today compared to a conventional vehicle, but in long term, let us say for using a EV for 10 to 15 years, the overall cost for running per kilometer cost will be less for electric vehicle compared to a petrol or diesel based vehicles. The second common myth is electric vehicles take very long time to do the charging, but the reality is that the time of electric vehicle charging, it depends on the type of charger we are using to do the charging. As per the Bureau of Energy Efficiency, the type of charger being divided into two groups. The first one is known as the slow or the moderate chargers and the second one is called the fast chargers. Normally, two-wheeler, three-wheeler and four-wheeler electric vehicles can be charged using a slow or moderate chargers up to 80% of the full battery capacity in up to 1 to 5 hours only. And if you are using a fast charger, these electric vehicles can be charged under less than 1 hour also. The fast chargers are mainly adopted to charge electric four-wheelers which normally have a bigger battery size. The next myth is electric vehicle batteries will only last a few years only. That means people are worried what will happen after few years of using a electric vehicle. You may require to purchase a new batteries, but this is not true. The reality is that the lifespan of battery is not very small. The idea of lifespan of battery is small comes to our mind because normally when you are using a mobile phone, we find that we need to replace the battery after a certain times. However, you need to understand that the mobile phone you are using it very vigorously and the batteries used in electric vehicles are very superior than the batteries used in the mobile phones, and the mobile phone batteries are very smaller in size also. Even if you go through the advertisements given by the electric vehicle manufacturers, it says that they provide a warranty on the batteries in the range of 5 to 8 years, which is a reasonable time to run a electric vehicle without any difficulty. Then the next common myth is the emission of a electric vehicle, it impacts more compared to a petrol and diesel vehicle. Actually, this is not true. Electric vehicles overall carbon footprint is very small compared to the carbon footprint of a petrol and diesel based vehicle. Of course, we are getting zero tailpipe emission. However, there will be little emission in the form of electricity being produced at the electric power plants. Again, here you need to consider that the conversion efficiency of electric vehicles lies in the range of 59 to 62%. Uh, uh, whereas this petrol engines, their conversion efficiency is very small in the range of 17 to 21% only. Even this CNG gases, which are considered to be cleaner than petrol and diesel, are also not good for the environment, because they also emit ammonia and produce particulate emissions, which is not good for the human being and the environment as a whole. Of course, the electricity that is generated at the electric power plants being used to run the EVs, so there will be some amount of pollution being created at the site of the electricity production. However, it depends on what type of electric power plants we have. For example, nuclear power plants considered to be relatively cleaner in sources. In view of this, India plans to achieve 40% of cumulative electric power installed capacity based on non-fossil fuel energy sources by the year 2030. In Europe, it has been observed from the study that petrol and diesel based vehicles emits 3 times more pollution compared to electric vehicles. Uh, their electric vehicle is considered to be more cleaner, because their electricity being generated mostly from the nuclear based energy only. Next myth is electric vehicles have a very low range, but the reality is that the range of electric vehicles that is available as on today is sufficient for most of the people who basically use a EV for their daily mileage of an Indian driver. As per the Bureau of Energy Efficiency, the average range of a electric two-wheeler in India today is around 84 km per full charge, and for car it is in the range of 150 to 200 km, where this average range, when you consider with continuously increasing charging infrastructure uh, uh, in the public sector, makes this commuting even intercities easier using EVs, because a few years from now public electric charging stations will be available, similar to petrol or diesel filling stations available across the point from place to place. People believe that electric vehicles are very slow and a very bad performance. However, this is not true. The reality is that electric vehicles perform better than petrol or diesel based vehicles, because they are more efficient and they have better acceleration compared to a petrol or diesel based vehicles. These electric vehicles are powered by an electric motor that generates torque instantly without any gears. Uh, so, the moment you push the accelerator, the electric vehicle will get accelerated from stationary without any time lag. However, this is not a perfect situation in case of a petrol or a diesel based vehicle. Another belief is that India's electric grid system is not presently suitable for electric vehicles, and this is totally false. The present electric vehicles that result in the reduction of life cycle carbon dioxide emissions, even the current Indian grid fuel mixes this one. So, presently India has committed of having 175 gigawatt of installed renewable energy capacity, and up to 450 gigawatt by the year 2030. So, the current weighted average emission factor of the country for the national grid has been nearly constant for past few years at 0.82 TCO2 per MHO, and this is based on the data available during the year 2018-2019. So, when you need to do the charging, uh, we think that sufficient charging stations are not available across the country, and the reality is that uh, presently the distance to which we make a cover on daily basis is relatively small except few people. That is why the full charge range presently available in the vehicles are sufficient for day to day life. However, uh, on daily basis there is a increase in the number of installations across the country in terms of charging electric vehicles. Then there is a common myth that electric vehicles get damaged when it waterlogged in waterlogged areas and are very dangerous to charge in the rainy season. The reality is that an undamaged electric vehicle provides a foolproof protection. That means the electrical components are well insulated and sealed like conventional electrical wiring systems we use at our at our home. There is a one standard known as IP67 rating. Here 67 represents the protection against two elements, that is dust and water. So, for the reference the value which is above 67 generally used for specialized equipments like submarines, where it should be 100% watertight systems. That means the electric systems in electric vehicles are foolproof, something similar to the technology being used in the submarines to protect water not entering into the electrical systems.